Hello and welcome to Mr. Wiley Teaches Math. Today we're going to be solving equations in more than one step. When we're solving these equations, our goal is always going to be to isolate or get by itself the variable on one side of the equation and all the numbers on the other side. Our end goal is going to look like something like x is equal to 3. We have the equal sign in the middle, variable on one side, and numbers on the other. It could also look like a number like 4 is equal to y. In this case, we have the number is equal to the variable. Either way, it'll be fine as long as all the numbers are on one side of the equal sign and all the variables are on the other. We're also going to go back at the end and check that our solution is correct by placing the answer back in the original question. So when we end up solving this, we'll put our answer back in and see if we got it correct. We have step-by-step to do this, a checklist to help us solve the equations. The very first thing we're going to do is look for a distributive property. If we see this distributive property like I do down here, that'll be the first thing we do. Second thing we're going to do is collect any like terms. So if we see anything that has any like terms in it, we're going to collect those first. Then we're going to work to isolate the variable. And we're going to do actually backwards to BEDMAS, it's kind of undoing that knot again, using addition or subtraction first, and then moving to multiplication division at the end. If you think of the exponents, if we had exponents in it, which we don't today, that would actually be the last thing that we'd undo. So in our first example, 2x plus 1 is equal to 9. I don't see any distributive property. I don't see any terms that I could collect. So I'm going to start isolating the variable using addition and subtraction first. So I see addition of 1, so I have to undo that. I'm going to do the opposite and subtract 1 from each side. So again, I'm going to 2x plus 1 subtract 1 is equal to 9 subtract 1. Okay, those go to 0, so I'm with 2x is equal to 8. Now I have to get rid of this 2 times x, so I do that by dividing by 2. So I get 2x divided by 2 is equal to 8 divided by 2. Those go to 1, x is equal to 4. So I can take my x is equal to 4 and drop it back into the original and see what happens. So 2x plus 1 is equal to 9 when x is equal to 4, like we did way back at the beginning of the unit. So let's substitute 2 times 4 plus 1, see if that equals 9. 2 times 4 is 8, 8 plus 1 has to equal 9, 9 equals 9. If those are actually the same number, it balances, we probably have it correct. So let's try the next one. Let's move on to x divided by 2 plus 5 is equal to 4. Again, I don't see any distributive property or terms to collect, so let's start by isolating by subtraction. Let's subtract 5 first. So I have x divided by 2 plus 5 subtract 5 is equal to 4 subtract 5. Alright, those go to 0, so I have x divided by 2 is equal to negative 1. That's alright, having an integer is alright. So x divided by 2, so I have to multiply both sides by 2 to undo that. So 2x divided by 2 is equal to negative 1 times 2. Again, those go to 1, so I end up with x is equal to negative 2. So I can put that back into my original and see if I get this correct. So we end up with negative 2 over 2 plus 5 has to be equal 4. Negative 2 divided by 2 is negative 1 plus 5 is equal to 4. Negative 1 plus 4, 4 equals 4. Hey, it checks out. 4 equals 4, yes it does. We can go on. Alright, this next one, I have 2, and then I have my distributive property, x minus 1 in brackets equals 10. So let's do their distributive property first. So let's do 2 times x, which is 2x, and 2 times negative 1, which is negative 2, which is equal to 10. Now I'm going back to, I have to get rid of the subtracting 2, so I'm going to add 2 to both sides. 2x minus 2 plus 2 is equal to 10 plus 2. So 2x on this side is equal to 12. 2 times x, so I'm going to divide by 2 again. 2x divided by 2 is equal to 12 divided by 2, x is equal to 6. So I can check that by putting it back into the original and see if it works. So I'm going to have 2 times, substitute the x for 6, minus 1. It has to equal 10. Let's see if it does. So 6 minus 1 is 5. 2 times 5 is got to equal 10. 10 is equal to 10. Same number again. I think we have it right. In our third example, we have some collecting like terms that we can do. I don't see any distributive properties, so let's collect the like terms. 3x plus 4x is 7x. 7x is equal to 14, or 7 times x, so I'm going to divide by 7. So 7x divided by 7 is the same as 14 divided by 7. Have to do it to both sides. So I'm going to simplify. That's going to go to 1, and then x is equal to 2. That was some simplification there, the very last step. Alright, this last one has quite a few steps in it. I have 5, and then 2x plus 1 in brackets plus 9 is equal to 2 in brackets x minus 2. So the first thing I'm going to do is distribute a property. Distribute a property off to the side. I'm going to do that on both sides at the same time. So 2 times 5 is 10x, and times 1 is 5, plus 9 is equal to, let's do the distributed property, 2x minus 4. Okay, I do see some terms on the same side of the equal sign that I can collect. I should have said that earlier. When I'm collecting like terms, let's collect them on the same side of the equal sign, so I'm not going to bring that across yet. So let's collect like terms. 10x plus 14 is equal to 2x minus 4. Okay, and then my goal here is to get the variables by themselves on one side. The problem I have is I have x's on this side and on this side. If I look at this one's larger, if I subtract 2x, it's going to still be a positive number, versus if I subtracted 10x, I'm going to end up with a negative variable, which is going to take a little bit of extra work to fix. So let's subtract 2x from both sides and see what happens. So 10x minus 2x plus still that 14 is equal to 2x minus 4. See where this gets us? This leaves us with 8x on this side plus 14. Those canceled out, so I'm just left with negative 4. And so now I'm still working to isolate. I see this positive 14. I'm going to move it to the other side because I want all the numbers on one side. So I'm going to subtract 14 from both. 8x plus 14, subtract 14, is equal to negative 4. Subtract 14. So I end up with 8x is equal to negative 18. I'm almost there. Going to end up with an integer solution, a rational solution. So I simplified. Now I'm going to divide by 8, the last step. So 8x divided by 8 is equal to negative 18 divided by 8. Those cancel out and go to x. And at this point I could think of this as, I could put it as a fraction. 8 goes into 18 2 times with 2 left over, 2 8ths, which is the same as x is equal to negative 2 1/4, or negative, I could write as x is equal to negative 2.25. Alright, thanks for watching. Be sure to check the class website for the assignments, the class notes, and additional examples.